Very good morning, sir, and very good morning to all joined in this live session. And I have posted the attendance form in the chat box. You can fill it up. I hope everyone filled it. And the feedback form will be given in the end of the session. And both attendance and feedbacks are mandatory for certificate. So while filling the attendance form, you will get the 4-digit pin, which will be used to fill the feedback form. Okay. So everything is fine. So now we'll start our today's session. So on behalf of Annakkili Research Institute, Chennai and e-teaching Tamil, I am glad to welcome you all to the second session of RE International ALGAL webinar series. I am very much proud and happy to introduce today's special guest, Dr. B N Verma sir. So Dr. B N Verma sir was born in 1943 and his age is today 77 almost. So he was superannuated and active service.
दो आवाज है,
अब ठीक हो जाएगा वहीं से।
Yes, sir.
आवाज ओवरलैपिंग करता है,
उनका इको कर रहा है, आपका इको।
He was active service as University Professor, University Department of Botany, BRA, Bihar University, Muzaffarpur, Bihar. And he is the pioneer phycologist who initiated and propagated phycological research in present Bihar. During 33 years of active service, he successfully conducted a number of major research projects sponsored by UGC, CSIR, DS3, Ministry of Environment and Forest under various ecological as well as Man and Biosphere Program and Ministry of Non-Conventional Source of Energy, Government of India. At least 20 research students were awarded PhD on various aspects of basics as well as applied phycology and limnology. He is has sponsored what's the and he has published more than 100 research papers, including establishment of many new taxa of green algae in scholarly journals of national and international repute, and authored 3 reference books. In addition to teaching, research, and writings, Professor Verma actively participated in academic deliberations and chaired a number of technical sessions. He also conducted a maiden exploration of edible mushrooms in Arunachal Pradesh. He was conferred Scientist of the Year 2001 award by National Environmental Science Academy of India and was facilitated by Tribhuvan University, Kathmandu, Nepal, in an international seminar held at Biragaj campus in 2002 on the recognition of his outstanding contribution in the field of plant science. He was elected member of Indo-Nepal Plant Science Forum under the banner of Tribhuvan University. He was honored by Indian Botanical Society on its 26th annual conference held in the year 2003 at Jamia Hamdard. And he also in annual and Phycological Society of India in a national symposium on biology and biodiversity of freshwater algae held in 2004 at University of Madras, Chennai. As an accomplished scientist with more than 33 years of research experience on service and also off service, he is more experienced. After his retirement also, still now he is continuing his research works and he is writing various books and research articles. So he has enormous experience in the field of algal science and cytotaxonomy. He is the pioneer of Indian cytotaxonomy and Chara and other Charophytes. So today he will explore all those things to us. So we will enjoy that session with you all. So welcome you, sir, to this session. So the stage is yours. You can start your presentation, sir.
Thank you. I'm sorry for starting my presentation with sense of sorry because of my delayed arrival at the place of presentation. It happened only because of the 2 reasons. First, I wrongly kept the timing of this presentation in my mind. Secondly, all of a sudden, it was scheduled to deliver the presentation from my hometown, Darbhanga, but at the 11th moment, the very poor connectivity, I couldn't make it possible from that place. And that's what I moved to Muzaffarpur, about 80 kilometers away from Darbhanga. And so, therefore, this is the reason for what Mr. Organizer had to reschedule my timing. Anyway, thank you very much, Mr. Perumal. And also, I want to express my heartfelt thanks to my very close colleague, and you can say mentor, Mr. Professor Chogule. After 7 years of my academic hibernation, following the death of my day, I was completely under hibernation, and I couldn't conduct any academic activity. But it was Mr. Chogule who inspired me and induced me and make me potent for starting my long due book and also on this type of academic intervention. So thank you very much, Chogule Sahab. And at the last, I want to share one proverb which my father used to repeat several times. And that proverb is, the poot kaput saput to kadhan sanchay, and poot kaput to kadhan, means if your son is able and worthy, you do not have to earn anything and to deposit anything for future, because son is your worthy. If your son is not worthy, even if you have earned and you have deposited a lot, he will just destroy it, misusing it. So at this moment, I remember because I don't know ABC of this new, I'm just a classical man of 81 years, and I don't know ABC of this e-teaching and e-academics. But I know everything by dint of my students, Professor K.K. Sahu and a number of my students, they are well versed with this new type of conferences and new type of academy, teaching and academics. So it is he made this presentation possible to do so. I'm very, I don't pay thanks. I bless my student K.K. Sahu. Now, starting to the topic, as you see, just Charophytes, Morphotaxonomy versus Cytotaxonomy. I choose this Charophytes due to the reason it's most fascinating group of, it constitutes a most fascinating group of algae at various level of its manifestation. Say, let's take the morphological manifestation. It belongs to Charophytes. It is supposed to have an undifferentiated thallus, having only dorsiventral differentiation or the filamentous-like structure. But unlike that, you can get and you can see that let you see in the slide that it has a very heavily branched and branches, even branches are dimorphic, and it's very highly elaborated at par with the higher plants. But even then, the thallus is haploid. Secondly, the genomic status. I used to say that Charophytes are haploid, but there is no authentication till now. No reduction division meiosis has been established, and it is just assuming the thallus is haploid. Second, the zygotic reproduction. The Charophytes used to characterize with unicellular sex organs, but many of you must have seen the sex organs of the Charophytes, which apparently appears multicellular globules, antheridia and oogonia, but due to morphologically, it is not apparently it looks like multicellular structure, but it is not so that, and that's why the term antheridia and oogonia has been replaced for globules and nucleus. Otherwise, it is highly well differentiated cell organs, unlike the common Charophytes. Zygotic generation, germination. You will find this zygote when it germinates like sending a protonemal like outlet, just comparable with the bryophyte. Now coming to cytological. Cytologically, if you see, you will find the chromosomes are well organized and very nice, showing distinct centromeric organization, localized centromeric organization, giving a, unlike the most of the Charophytes and the algae especially, are usually haploids. But even if its chromosomal organization is very, very minute, and you can hardly see the centromere therein. But the cytological Charophytes show a very high degree of differentiation of the chromosomes, well organized, well sized, and with distinct centromeres, all that, and having the clear-cut polyploid series, very long polyploid series, whereas in common Anthrophytes and especially the other algae, the aneuploidy is prevalent, but Charophyta is polyploid, very distinct polyploid, except it's one genus, that is Tolipela, which shows the aneuploidy. Otherwise, the most of the members of two tribes, it is having two tribes, the Annakkili and Kari, both are shows, of course, having the different basic number, but shows the distinct polyploid source. So these are all the special features with the Charophytes that I selected these Charophytes for my presentation. In fact, the presentation which I going to present, the data and all things, this belongs to a thesis of one of my student, Professor Lakshman Lab. He did a lot on these Charophytes, and this presentation is based on the basis of his findings. Now, coming to the algal cytology, the godward is supposed to be the mother of the algal cytology. See, many of the Indian phycologists, today's or yesterday's phycologists of India, they worked under the godward, and she covered almost many classes of algae for his cytological investigations. Coming to the topic of my presentation, the Charophytes, morphotaxonomy versus cytotaxonomy. Just I told you, described you about the facts for which this Charophytes was selected for the presentation. Now, next. Charophytes constitute a fascinating group of small but coherent natural assemblies, unique cryptogram, represented by no more than 400 taxa distributed all worldwide, primarily in freshwater. So it is coherent. I have used the word coherent because although it is represented by 8 living genera, and all the living genera are very close in having the same pattern of thallus organization, chromosome organization, and centromeric organization, all that, except a few in which the degree of haploidy, polyploidy and euploidy varies. Otherwise, it is very similar and no difference. Although Charophytes appear quite late during Silurian period, about 443 million years ago, as against the ancient green algae of chlorocrocodian affinity, which came into existence pretty earlier during pre-Cambrian around 900 million years ago. Geological evidence doesn't provide any clue of its phylogenetic or relationship. So it's all phylogenetic relationship depends on the comparative study of morphology, reproduction, cytology, and all that. In absence of geological evidence, immediate ancestry of the group therefore can be discussed only on the comparative considerations of the morphology and the cytology of living forms. It is beyond the scope a time-bound presentation to cover both aspects of studies made. Therefore, only the karyological findings recorded so far will be discussed in my presentation.
Can you play the PPT, sir? He is not playing the PPT.
Karyological.
Yeah.
Karyological study of the group was initiated at the onset of current century with the hope of resolving phylogenetic and taxonomical riddles, but active researches were done only after 1950. Since then, quite a good number of Charophyte taxa have been cytological studied so far. Just as I told you that the people going to United Kingdom working under the government in the different fields of algae, among all, they returned back to the India and first started and initiated the cytological work in algae. And at least in the Charophytes, I can say there are two bases, which primarily one, the BHU, under the leadership of Vice Chancellor mine, he first stood, especially the moment he worked very hard, very.
Hello, sir. Can you hear me?
Conducted successfully the major research project of on the Charophytes by DST. So all these amounted to accumulation of good cytological data and to interpret many issues of taxonomy, many issues of phylogeny. Let's say these are the chromosome numbers reported so far in the different species of the Chara. Just see one very peculiar thing. In Charophytes, you will find that the same chromosome number is shared by a large number of the taxa. Just see here, the 14 has been shared, a number of large taxa. Otherwise, the 7, the 14, the 35, for the all are in multicolor to cut multiple of 7, showing the polyploid 3. Here also it has reached to up to the 63, in case of Chara fibrosa, Vara fibrosa, Forma formis fibrosa. So again here that there is the predominance of the 14 chromosome number are in multiple of 7. Here also all are in multiple of 7, 35, 42, and so on. So all are in multiple, clear cut distinct polyploid 3 in multiple of 7. Here, this is again the 42, so even 70, the maximum highest chromosome number reported in Cara zelenica, Forma, Humboldt, yeah, this is up to 10-fold polyploidy has been reported in this case. I think this is the highest number. Again, next. Now it is the Lycnothamnus. Again, another genus of the Charophyta, Lycnothamnus. This is there is a predominance of 14 chromosome count. That I told you, I say it is haploid, but there's no authenticity because the meiosis has not been established and studied so far in the Charophytes. But assuming haploid, these are the haploid number, and the maximum number in this case has been reported 35. So only the 5-fold increase in the genomic set. Lycnothamnus, so there is a poor polyploid series in case of Lycnothamnus. Next. Now coming to this Nightella, this is showing the Nightella. Just see, unlike the in multiple of 7, here we see in multiple of all the chromosomes are in multiple of 6, and sometimes other there is a controversy that we will show you later. There is a controversy about its basic number. All postulate its basic number 6, but Sharma proposed its basic number 3. So if we are taking 3, then the polyploid, we can conclude the Nightella more high polyploids than compared to the Cara. But when we assume the chromosome basic number 6, then we see there that much of polyploid is not seen in case of the Nightella. Here, this is, unlike the 14 number in Cara, we are see the 18 is shared by most of the taxa. Otherwise, just multiple of 6, but especially in the multiple of 3, all the chromosomes showing a clear-cut polyploid 3. Next. Here, the maximum number 46 has been, and say if we are adhering to the basic number 43, then it goes very pretty hard polyploids in case of Nightella, unlike against the Cara. But if you are assuming the basic number 6, then it comes down below the Cara. Again, this is a clear-cut polyploid series here in this case also. Okay. Next. This is also all the chromosome numbers shown in multiple of 3, 15, 27, 24, 18. So I mean, there is no record of aneuploidy. Very few of the taxa have been reported with aneuploid. Otherwise, majority of the taxa show the distinct polyploid series with euploidy. Next. This is again the Tolipella. Just see, unlike we have seen the Nightella, Lycnothamnus, and Charophyta, there is a distinct polyploid. So just see, there is no definite pattern of numerical variation here. Just see 12, 33, 10, 11, 13, showing there by that. Unlike the Cara and Nightella, this Tolipella genus exhibits the predominance of aneuploidy, and polyploidy is not here. Just next. Just see. The chromosomes here in the Charophytes, that about this we will discuss later while dealing with the cytology, but you can see the chromosomes are of quite good size, having the distinct constrictions showing the position of centromere, and here is that 14, 14, 14, all that. So chromosome, well-organized chromosome. This is the case with the, इसके नीचे होगा, Cara. This is all the chromosomes showing the count in Kara. Next. Deskachari and Sundaralingam and Morris advocated for Charophytes origin of Charophytes on account of its close similarity with Dapplidopsis in regard to the thallus organization. Just I tell you, just that vegetative thallus of these Charophytes have a well-organized branch thallus having the dimorphic forms, the branches of limited growth arising from the nodes, the branches. There is differentiation of the nodes and internodes like the higher plants. The branches of limited and unlimited growth both arising from the nodal region. So it shows the similar pattern of thallus organization what we see in case of Dapplidopsis of Charophytes. In Dapplidopsis also, the thallus, the difference between Dapplidopsis and Dapplidopsis is this, that although Dapplidopsis is also highly branched, but having no differentiation of the short and long cells, short nodal cells, and the long internodal cells in case of Dapplidopsis, but it is seen clear-cut in case of a Dapplidopsis, and in this context, it is most very close and comparable with the thallus organization of the Charophytes. Just see, this is the natural thallus of the Chara showing its mode of branching. These are the short limited branches and unlimited yard. This is the case with the Chara. This is the sex organs. Just see, very clear-cut. I will show you next slide. There is clear-cut multicellularity. The organization of these sex organs, the yellowish color denoting the nucleus, and the below the reddish color is and globule that is equivalent to entheridium. Just see, above is the corona. It is one for number of 5, and it is added only unicellular one layer corona. This is the characteristic of the Chari and Chara, and just above nucleus, below is globule. This is the characteristic of the Chara. This is again the Chara, the cell cells, is the multicellular nature of this entheridium, that is globule, and just see the tube cells around the egg and upper the corona cell, which is arranged in one tier. You will see this tier corona cell will be having 10 in 2 tiers, one bicellular corona cell. In case of the Nightella, just see, this is the Lycnothymus growing in natural habitat, showing the belonging to the this Chari tribe, close to Chara. This is the Nightella. Just see, this is also equally well branched, having the dimorphic branching showing. So this is the Nightella, thallus of the Nightella. This is about the Tolipa, how beautiful it represents in accurate here. You can see very good growth and ornamental appearance inside the. It always grows in fresh water. You can see very clear cut organization of the thallus deep in the water. This is again the Tolipella. This is just see, Desikachari, who advocated its derivation of the Charophytes on the basis of the similarity of just see here it is laterally showing the branches of limited yet like that. It is just a clump of heavily branched thallus of the Dapplidopsis, resembling very much with the habit of the Cara and Nightella, and that's why it's phylogenetic relationship shown with the Chaetophorales and with the Charophytes. So this is just the morphological appearance that resemble very much. This is the branching pattern of the Daphnidiopsis in case of the Daphnidiopsis. This is the Daphnidia. Just see, there is no differentiation. Although branches are coming out, but coming out with not differentiated shorter and longer cells. Shorter cells are the nodal cells. That differentiation of short and not long cell is not here in the case of Daphnidia. This is the only difference. This is again Daphnidia showing the branching habit. This is again the Daphnidia. So you just see there is no differentiation of the short and long cells, unlike the Daphnidiopsis. This is the difference, that in case of the Daphnidiopsis, it is differentiated short nodal cells from which the branches come out, and here long not coming out from the long cell. Here there is no such differentiation of the nodal and internodal cells. Just see, this is about what we have seen, that is the external resemblance. But when we come to the cytological level, you can see just how short, very minute chromosomes here. Just how minute chromosomes here, just very small, not at all comparable with anyway with the Charophytes. Even you can't see the centromere here, hardly you can just measure it so short. So it's unlike the Charophytes, Chaetophorales, in spite of having close similarity morphologically, it is quite dissimilar in case of its chromosomes. Also, one thing, just the chromosome number here doesn't follow any just definite pattern of variations, that is in multiple of any basic chromosome number. So all basic chromosome number is altogether absent in case of the Daphnidiopsis. This is another cause of difference between the two. Here, just see, this is the Stereoclonium, another member of the Chaetophorales. It is also well characterized with highly prong thallus. But the chromosome here is again very small, and even centromere is not detectable. Hard you can just even you can't assume where is centromere is so short. This is the chromosome showing the Daphnidiopsis. You can see how minute structures here are. You can't even say where is centromere, very small. So this is altogether quite different from the Charophytian chromosomes. There is no resemblance between the Chaetophorales and the Charales as regards the cytological features. Again, it is the Daphnidiopsis chromosome. This is again the chromosomes of Daphnidiopsis. Now, the karyotypical data of Charophytes and Daphnidiopsis, however, do not support hypothesis of Charophytian origin of the, for the reasons derivation of large chromosomes of Charophyta from very small chromosomes of Chaetophorales seems impossible. You can just assume and you can dream of the derivation of a small chromosomes from the bigger chromosomes. But it seems very impossible, but it's a very minute chromosomes would have given rise to very long and established, well-organized centromeric chromosomes. It appears unlikely. Polyploidy is predominating means of numerical variation in Charophyta, while aneuploidy is a common feature of Chaetophorales. Just tell you, I have shown you, there is no any definite pattern of numerical variation in the chromosome number of Chaetophorales, 2, 3, 7, 10, 9, irrelevant variations without any definite pattern. But in Charophytes, there are two series of variations. One, bearing the polyphylla in which the aneuploidy is prevalent. The two genera have a distinct polyploid serial in multiple of its basic number 6 or 3 in case of Annakkili or 7 in case of Carry. Charophytes bear most primitive haploid life cycle and Delegates possess isomorphic alternation of generation, derivation of in reverse direction doesn't seem convincing. Although just I'm describing here that the plant body is haploid, although I told you there is no confirmation of any meiosis or the diploid phase in Charophytes, although that we assume, since it is being counted in the sex organs, nucleus and globule, and the same chromosome number is counted in the vegetative thallus. Of course, most of the studies have been made on the chromosome of the nucleus endothelial filaments, but there are few people who have worked also on the vegetative thallus chromosomes of the vegetative thallus of the Charophytes. So perhaps Samit and Praveer Chatterjee in West Bengal, they have worked, and the same chromosome number is seen in both cases. On that basis, it is supposed that the thallus is haploid. And if it's so, the thallus of Charophytes is haploid, whereas the Delegates possess isomorphic alteration generation in which both the haploid and diploid generation is equally established. Derivation in a reverse direction doesn't seem convincing. The derivation of primitive haploid life cycle from isomorphic alternation of generation in reverse direction doesn't appear convincing. Therefore, whatever we see the similarity in morphological organization of the Charophytes and between the Charophytes and the Chaetophoralian members like the Tapelia, Diopsis, Stereoclonium, all the forms are not, of course, Chaetophora, most of the forms are well branched. So that similarity appears only due to the parallelism. Parallelism is a very common feature in this, in the algae as a whole. Affinity of Charophyta with green algae by earlier workers also seems not convincing. Possession of well-organized chromosomes with distinct localized centromere and prevalence of polyploidy observed in Charophyta favor its closeness more than higher plants than with green algae in general. That we have discussed. Just if at all any similarity is to be made, then you can compare the chromosome of Charophyta with the higher plants in which we see the distinct polyploidy, distinct localized centromere, quite distinct big size of the chromosomes in all that cases. Instead of resembling with the general green algae, in which case there is prevalence of aneuploidy, the chromosomes are very minute, but it's very close to the higher plants in which just like the Charophytes, it is having the well-organized centromere, big size, distinct polyploid series. Systematic position of Charophytes has been a point of dispute from very beginning. Pilinia secundus describe it as a species of inclusion. Just you have seen just we have seen in the last slides. It is just like the ecogetium, like the ecogetium 2, having the so long and short cilia, the nodal, the branches comes out of two types. So exactly like that, probably because of that external similarity, morphological similarity, Pelagius secundus proposed its derivation, the placement along with the ecogetium. Adamson described it along with higher plants. Quite similar, the measures and gross similarity, cytological similarity, very close to the higher plants. So probably due to that, Adamson proposed his presentation, post allocation along with the higher plants. Strasburger kept it under Thallophyta between Bryophyta and Algae. Frisch and as we treated as a green order and class of green algae. Wood and Umauri and Van den Haag treated it as an independent division, Charophyta on the base. Apparently, one is very much convinced, rather wise to place it independently because of many characters. Just see, we have seen the thallus organization, so elaborated thallus organization, branching, elaborated branching habit, the erect thallus, and all that, the chromosomes organization, localization of distinct localized centromere, position of basic number, prevalence of all these characters. It is quite, although it resembles with higher parts, but it's not possible to place it along with the higher parts. We'll have to keep it with algae and with the algae, but with an independent status that would have already, and when they given that special status to this charophyte. Aforesaid karyological features of charophytes do not have match with any other group of chlorophytes except cladophorales. Of course, if at all if you are comparing it, so on the basis of the cytology, if there is any resemblance of this charophytes, there is resemblance with the cladophorales, in which there is a distinct, that I will show you the slides. This cladophorales is also, although the unbranched filamentous genera are there, but the branched filamentous genera also prevails in the cladophorales. Not only that, when you will see the chromosomes that we will see in subsequent slides, you will see that the chromosomes are quite bigger and good size, having a distinct centromere, just as we have seen in case of the charophytes. So if at all any similarity is to seek with any other group of the green algae, it is only cladophorales, so with which it can be compared. Cladophorales possess equally well organized chromosomes with localized centromere and predominance of polyploidy. In cladophorales, the component taxa are united more coherently through a single basic number 6 as against two basic numbers 6 and 7 representing two different tribes of the order. That actually just I'm coming to the one fact. If at all you are taking the karyology as the basis of comparison, then you can say the cladophorales is more stable, having a single, all the genera are knit together with a single basic chromosome number. But when you will come to the charophytes, we'll see cytologically it is just a heterogeneous. When you are taking that, we will show you later, when we are taking the lichnothymous, it is having no distinct polyploidy. When you will see the Cara and Nitella, these two genera having a distinct and predominance of the polyploidy, but the aneuploidy you can see in exceptional cases. And then you will, when you are coming to the Tolipella, there is no polyploidy, the predominance of aneuploidy. So cytologically, you cannot say it is a coherent group, it is diverse in nature. But in case of the cladophores, cytologically, it is more stable and coherent group, all the genera knit together with only one basic chromosome number. Just see, this is the image of the cladophora showing the branching habit resembling the Charophytes. Just see, these are the two species of the cladophora showing heavy branching compared with the Charophytes. Just see, this is the chromosome of the cladophora intermedia. You can see that's just like we have seen the Charophytes. Just at par with it, the chromosomes are quite big size, having a clear-cut indication of the centromeric locations. So in this respect, it is more closer to the Charophytes other than any other members of the Charophytes. Here, this is the Cladophora farcata. Here, just you see, this here is also just chromosomes are quite bigger, having a distinct indication of the centromeric location. This is the rhizochronium. That's of course, this is the unbranched filament, the thallus of this rhizochromia, unbranched filaments, but having the same predominance of the polyploidy and well-organized chromosomes. There is no genetic variations in regard to the organization of the chromosomes or the location of the centromeres and predominance of euploidy. This is again the rhizochronium showing the big, the bending showing the position of the centromeres, so quite similar to the Charophytes. So, if any effort is made to separate Charophyta from the class Chlorophytes exclusively on karyoidal ground, the cladophorus deserves same treatment which doesn't seem justified. Of course, it can be claimed on the basis of the cytological data, but alone cytological data cannot make the basis of such a big decision. When Charophyta, besides this cytological examination, you have seen the organization, the brachytic mode of germination of the zygote, and the formation of the complex sesquioid. These are the points which makes the Charophyta quite different, and that sort of things we don't see in cladophorus. So in my opinion, it's not advisable to place it under the independent division Charophyta along with the Charophyta, that is the Cladophorophyta. Not, I disagree, and it cannot be compared in this regard with the Charophyta for placing the, giving the special status. Charophyta includes 4 families: Trachiliaceae, Cediaceae, Cladotosaceae, and Caraceae. Of all these 4 classes, families, 3 belongs to the fossil members, and the Caraceae is only representing the living member. Of the 4, first 3 are fossil forms, and last 1 living form represented by 8 genera: Cara, Protochira, Lichnothymus, belong to the tribe Cari, and Nitella, Tolipella, Charophytes, Lanthrothymus, and Nitellapsis belongs to Nitella. Of all these 8, most frequently cytologically analyzed genera, Cara and Nitella, to some extent Tolipella, and Lichnothamnus. Two very few of the species have been cytologically investigated, not the protocollic, and other groups are not well studied in regard to its chromosome organization. Basis of genetic distinction: number of crown cells, 5 in one tire in Karya and 10 in two tires. Just I have shown you the corona one tire denoting the careso exactly. In case of nitrogen, the corona remains the same position, but instead of unicellular, it becomes bicellular 2. So number of cells becomes, instead of 5, it becomes 2. And again, instead of being arranged in one tire, it is being arranged in two tires. Corticate or ecorticate. Annakkili is completely ecorticate, but there exists a wide variation in regard to the cortication and ecortication in case of the carry. Monopodial or sympodial, the mode of branching to are the basis of genetic differentiation, distinction. Disposition of Antheradia and Oogonia. Just I have showed you the nuclei in Cara, nucleus is above, and globule is lower, just reverse in Nitella, in Tolipella, in a state of having one, each state having one globule, and Antheradia, it is having 2. So these are on the basis of the disposition of 6 sex organs, Antheradia and Oogonia, the genetic distinctions are made. Regan et al. Advocates for inclusion of Cara and Nitella together in a single taxon, Carols and Carici, or Carici on the basis of the 18S RNA gene sequencing. Karyological data, basic numbers, support their separation into different types under the order carriers proposed on the basis of distinct morphological and character. That we have seen just on molecular level, everything becomes molecular. So at that level, that differentiation may be lacking. But when we see the distinction of the two distinct basic number of the Cari and Nitella, then we cannot agree with the convergence of these two genera into one. So karyological interference is more convincing and supporting. The tribe Cari, although exhibits wide range of morphological variations underneath, karyologically appears to be natural assemblage.
Sir, have some water, sir, please. Please, you are troubling. Have some water, sir. You are getting some throat air, these things.
Pramod.
Drink water, sir. Yes, thank you, sir. Thank you, sir. Continue, sir.
The tribe Cari, although exhibits a wide range of morphological variations underneath, karyological appears to be natural assemblage and a stable being knit together conservatively with single basic. Just we have seen the morphologically, although quite variations occurs within the Cari, Caliclothanus and all that, but cytologically it moves coherent because only one basic number is there. But when we come to Annakkili, we see the Tolipella doesn't follow any definite basic number, and the aneuploidy is prevalent. But Nitella, there is so that Annakkili compared to the Cari, Annakkili appears to be less natural assemblage rather than the Cari. The tribe Annakkili, on the other hand, doesn't seem to be natural assemblage karyologically on account of its controversial basic chromosome number. Gillette. For Annakkili, just I told you, the sin is one basic number unanimously accepted for carry. But Annakkili, it has been Gillette proposed 6 as the basic number in Nightella. Maori and Cato proposed 6 and 7 as the basic number. Hotchkiss proposed 6 and 9 as basic number. It is Sharma and Khan suggested basic number of the genus Nightella as 3, claiming the existence of 2 distinct sets of 3 chromosomes. If adhered to Sharma and Khan, then we can just establish the truth of true polyploid series in case of the Nightella, and if you assume that 3 is basic number, then in the, as against the general assumption that the carry group is more able in regard to the attaining high polyploid level, goes wrong, then Nightella will become more higher polyploid in showing the higher degree of polyploidy. Polypola, just told you, prevalence of aneuploidy as against usual predominance of polyploidy, the Charophyta as a whole. Variable basic numbers have been proposed for the genus Polypola as below. Just where we don't have any definite pattern of chromosome number variation in Polypola, so it's just useless to go for any basic. However, Godless has proposed the 5 or 10 for the as a basic number for the Polypola. Hotchkiss has proposed 11 and Shava has proposed as 3. But to me, it doesn't, neither of the any basic number comes true because it's highly aneuploidy and there is no any distinct series. So a few polyploid series, short polyploid series can be seen, but not like that. Now, how does polyploids? See, there is the Charophyte shows quite predominance of polyploidy, and how this polyploidy is attained in the Charophyta. Just these are the region. Non-negotiable meiosis in the oospore carrying non-homologous genomes or through chromosomes doubling during some stages of oogonial development in Kara canescence. This was told by Tyndall and Sava in 1964. Due to doubling of chromosomes in the enthelial filaments, this was postulated by Tyndall and Sava and Imari and Cato. In the polyploidy, in certain cells of enthelial filaments of Cara leptopitis may be the cause of polyploidy as conceived by Hutchinson. After analyzing the karyotypes of Nightella opaca and with N6 and N flacilis, N6 and 12, Sava 1965, concluded origin of N flacilis due to the hybridization between N opaca and an unknown species of Nightella with N6. Charophytes resemble with higher plants, showing chromosomes with localized distinct centromeres and predominance of euploidy, but differ from higher plants where reduction in chromosome size is pre-adaptation for polyploidy. The Charophytes display long polyploid series with large chromosomes. The reason behind it has been given, may be given, that the short life and fast vegetative propagation probably rendered the Charophyte to adapt polyploids unhindered even with large chromosomes. Goreskin, 1967, and Sharma and Ramji, after assessing the frequency and degree of polyploidy, concluded Cara is well ahead with 58% euploidy against only 38.5% in Nightella. If we assume 3 as a basic number of, then this conclusion will go wrong. A striking feature of Charophyta is that its single taxon, the most difficult part that prevails in the Charophytes is the striking feature of Charophyta is that its single taxon may exist at different ploidy levels in nature without any appreciable morphological changes. In contrast to higher plants, such polyploids have been called cryptic polyploid by Davis and Howe. This is very interesting. In table we have shown there are 2 peculiarities of the Charophytes. One thing, that is the same chromosome number with insignificant and very non-relevant karyotypic differentiation. It's shared by a large number of the taxa. That's we have seen the 14 is shared by a huge number of the taxa, and when you will go to the karyotype details, then you will find not much taxonomical level difference lies in between them. So this is the and another thing in higher plants, when higher plants having the high polyploidy gives the morphological exaggeration, but not the lower polyploids. But as against that, when you will see the examples of the Charophyta, I will see even the 70 chromosome number bearing filaments remains the same in outlook, which is bearing only the 14. So there is no morphological exaggeration in case of the Charophyta, and that's why it has been termed a cryptic polyploids by Davis and Howe. Predominance of aneuploidy in Charophytes. Just I told you that Echinothalmus having no aneuploid polyploid reported. Cara and Nightella having the occasional occurrence of aneuploidy, and Tolipella predominance of aneuploidy. Though aneuploidy is not a common feature of Charophyta in general, yet emphasis has been given on its key role in generic evolution and that of euploidy in speciation. Just see, in Tolipella we have seen irrelevant variations not having following any difference. So any number can be because of the predominance of aneuploidy in case of Tolipella. So any number can be supposed to be derived in the form of the basic number 6 or basic number 3 or basic number 7. So it is when we take the aneuploidy, we can assume that might have played a good role in the generic differentiation of in Charophytes, but when we are taking the specific level, it is the polyploidy which plays a significant role in Charophyta. Another cardiological feature of Charophytes that come in the way of taxonomical treatment is sharing of same chromosome number by different taxa with almost overlapping cardiological features. I told you, the same number, you will see a large number of the taxa sharing the same number when you will go with a morphological study of the individual chromosomes in the criotope, adhering to the classical observation. Then you will hardly see any taxonomically significant variation in that character. So that's a very difficult part. The only way any device should be developed, nowadays the banding has been developed in case of the study of chromosome study. But unfortunately, not that banding practices have been employed in case. So only the Praveen Chatterjee under the supervision of Praveen Chatterjee and Shamit Ray, I find only one reference that they attempted the Jimsa banding in case of the Kara. Chatterjee and Ray in the year 1986 attempted Jimsa C banding in Kara Brunei forma Perotetii to differentiate the chromosome complement of karyotype with characteristic banding pattern of its own. So it is the only reference we get of practices of banding in charophyte. Just see, this is the part of the publication of Chatterjee and Shamit. This is sort of banding. Practices are employed and in majority of the charophytes, then we can able to differentiate that similarity of similar chromosome sharing the different by the different taxa. You can differentiate that karyotype on the basis of this banding pattern. But unfortunately, it passed almost 35 years that this practice was adopted and published. And thereafter, so far my knowledge goes, no banding study has been made in the charophytes. I think this will give a greater solution, greater relief in resolving that sort of overlapping and confusing facts. No positive correlation had been reported between chromosome number and any morphological features of taxonomical importance at inter or intra-specific level. There is no any problem. If you want to correlate the chromosome number with any morphological trait, particularly dactyly or orthodactyly and the sex organ position, then you will find no correlation, a statistically significant correlation altogether absent. Few of the basic characters on which taxonomy of the charophytes are based and their phylogenetic implications have been debatable or resolved with karyotypic data. Monoecious versus dioecious. The monoecious, it is assumed, Wood and Emory. Dioecious forms are genetic variant of monoecious forms being possessing double chromosome number than dioecious. According to what he says, he assumed that dioecious is having the half number of the chromosome than the monoecious. But we'll see it is not true. Sava suggested origin of Nigella flaxseed. Monoecious with N12 originated through hybridization between two dioecious taxa carrying chromosome number N6 each. Tyndall and Sava, Hotchkiss 63, Khan and Sarah 67, however, reported same chromosome number in monoecious and dioecious form. So all assumptions goes wrong if we are adhering to the findings of the Tyndall, Sava, Khan and Sarma and Hotchkiss. My student Love also not recorded any correlation of karyomorphological features with distribution of sex organs in charophytes. Verma. Under one project, DST project, I also conducted the survey, taxonomical survey and cytological survey of Charophytes of North Bihar, and then I could also see since there is no record of sex-linked chromosome heteromorphism, sex expression in Charophytes in presumed molecular level. Corticate versus ecorticate. Carologists are divided over the phylogenetic status of corticate and ecorticate forms in Cari, Wormersley, Annakkili, and Kasaki. Consider ecorticate forms primitive, whereas Desikachari and Sundaralingam and Wood and Imahuri considered ecorticate forms advanced. Sharma et al. Corticate forms are advanced on account of fetching high frequency of polyploidy. Love, ecorticate forms are primitive on the basis of the symmetry of karyotype, that is minimum coefficient of variation among the chromosome complement of karyotype and TF%. Now to me, now to me, if we are adhering just previous pages, slides I have concluded that the aneuploidy plays a significant role on the genetic differentiation. Then the aneuploidy, if at all it gave rise to the formation of new genera through aneuploidy, then the aneuploidy is prevalent in Talipela. The karyotypes is more unstable in regard to the ploidy. It is highly aneuploid, and from that, very easy to derive any basic number for the Cari and Nitella. So to me, I support the ecorticate as primitive. Haploestephanous and diploestephanous. Diploestephanous forms are advanced than haploestephanous forms on the basis of the symmetry of karyotype, such as smaller chromatin length followed by higher coefficient of variations among chromosome complement of the karyotype, concluded advancement of diploestephanous from forms over the haploestephanous forms. However, both forms scored equal TA%, so there is no very convincing conclusion. Anarthodactyly versus arthodactyly. Wood and Imahuri consider as anarthodactyly more advanced, and Sharma and Ramji are arthodactyly on account of scoring higher frequency of polyploidy is comparatively advanced. Love. In conclusive, even after analyzing karyotype of more than 50 taxa of charophyte. Thank you very much for bearing me and for excusing me for late presentations, and especially to Mr. Professor Perumal, who might have faced many trouble due to my late arrival for presentation. So thank you very much.
Thank you, sir. It was a nice, great session, and I have to be grateful to you and the audience. They were also like too much patient to wait for the session, and even though we had a lot of technical issues, And finally, we concluded the session with the great things. And there are some of the these things are like questions. So can you answer them, sir?
आंसर करेंगे क्वेश्चन का जवाब दीजिएगा सर. Yes, yes,
Yeah.
कुछ क्वेश्चन पूछा जा रहा है.
I'm open for that.
So what are the major challenges nowadays on charophyte research?
Main challenges is, I told you, okay, you mean the psychologically or morphologically? Cytologically, the main challenge is that there is quite large number of the taxa are sharing the same chromosome number with distinct conventional morphological details. So its banding pattern only can give you the answer to this question. The main challenging is that. Second challenging is that even if the charophytes attaining a high degree of polyploidy, but with no morphological manifestation, how takes place? Why, when the duplication, and so on, it leads to the morphological enlargement of the morphological parts. Why not it is taking place in this charophytes? I don't know. Second thing, we just say, going on saying this is haploid, but till now, the main challenge I see, the establishment of its diploid phase. It has not been so far established in case of the charophyte. So to me, these 3 points are very challenging and needs further investigation and keen interest.
Okay, sir. Thank you, sir. And what is the impact of water quality on charophytes, and also the pH impacts on charophytes? What are the impacts of water quality and pH impacts on the charophytes?
That part has not been done by you, but the charophytes are the freshwater lover. And in freshwater, however, it has been reported, it proliferates more fastly than any aquatic higher plant site. It makes a predominance over it. So the freshwater, sweet water, is preferred by these charophytes.
Sir. Thank you, sir. And is like reactive oxygen, that like that also they have asked, but we'll skip that question. How to separate chromosomes from these algae, like this cytological study, how you are doing, sir? Can you explain that methodology or something?
Separation of the chromosomes.
Yes, sir. Chromosome. Looking under microscope, how we are doing that cytological study? Karyotyping.
No, it's separation. It's very simple. If you are doing it with the globule, normally it is done with globule. Globule has even shorter filaments than your antheridium stamens. So it's very simple. More difficulty is that it is in very close discoid cells are present there with very delicate cells. Even if you are making a more pressure, then one metaphase will mix with other. So it's very simple and gentle. Gentle pressing requires not much tapping. It's very simple to explain. But when you are doing it with a vegetative thallus, a lot of trouble, lot of treatments, and will be needed to just to wash out the pigments, the photosynthetic products and all that. So that part has not been done by me, but I assume some works have been done on the vegetative thallus of the chromosomes of the vegetative thallus, but it might be involving lot of trouble, but apparently because of the clearance of the pigments, photo reserve, the cellular, the thick cell wall, that even strong tapping will not admit the spreading of the chromosomes. So when you are doing normally, it is done with a globule, not nucleus, globule. Globule is very, just you will have to, under dissecting microscope, you will have to operate with a needle to bring out the antheridium. Just take a drop of ferric acetylcarmine with a ferric chloride, to be treated with the ferric chloride, and then put it on the slide and press it very gently, not very hard. Then, and it will, apparently it will burst and spread the antheridial filaments, just like the uniseriate filaments, delicate filaments. And within that, you will find the chromosomes. The precautions should be given, not much pressing should be done, otherwise one metaphase will merge with the other and make the counting very difficult. This is the major part. Otherwise, very simple, it's very simple.
Okay, thank you, sir. You explained it very deep in detail. And there is one more question. Okay, thanks. So people are posting so many, so it's running. Okay, sir. And Professor Sundarlingam has identified a few varieties of Chiara Ceylanica. Recently, I have collected a few samples which differ morphologically from these. Variations also observed in some of zoospore, that is scanning electron microscopy studies also showing the differences, and also molecular studies also confirm it. Can these be considered as new varieties?
Just see, you might have seen in CAD, that's why the nucleocytology were undertaken, that I told you, due to this, because of the very minute morphological variations, new varieties, even the genus, species, varieties, forma, and so on. So this is just a magical practices. It's very difficult. Sometimes the people are separate, recognizing many varieties, many forma under varieties and all, and sometimes you will feel that all are being amalgamated. So it is just a very dramatic scene in case of the Charophytes taxonomy, and that's why the cytology was undertaken. But in the case of the cytology also, that overlapping and the sharing prevails even in cytology. So new approach will have to adapt, whether they just either the banding or any other type, or if you now molecular level, the people have done molecular level, or sometimes the DNA extraction is taken and again then estimation is made. So all that part has not been covered by me, but that part might be helpful. But apparently in case of the chromosome number, the same degree of controversy and confusion prevails when you are coming to the cytological data. So you are saying someone getting the a small variation and suggested it is that this is a new forma under this variety, and unless you are not, I tell you one example. Once I had gone to a rural area and passing through the pedestrian road, which was muddy and just, and then I found a moss-like structure, something growing there. And when I took it in hand and observed in the laboratory, I found that was the member of the Charophyte. So much morphological deformation has gone there. And if anyone people is taking describing it, oh, it is a new form. So this is the practice. You can't help. I don't say what to say, but it is very confusing, and the aquatic habit itself an unstable medium, and that unstable medium provides various types of the ecological variations, and these ecological variations affects the morphological manifestations of the charophytes, not only the charophytes, but others in other algae, because simply the variation will take place only in the dimension of the cells. But here there are so many morphological traits, dactyls, all that, many things. So any short change can be expected with minute ecological variations. And on that basis, if we are suggesting new forma, I think this is not a good practice.
Okay, sir. And how to identify the charophyte species, sir? Species level identification.
Identification, the measurement of the globule, locules, the dactyl nature, stipules, arrangement, and all that. There are very big band of morphological characters we have in charophyte. So all the measurements should be perfect. And I tell you, if it also should be mentioned the conditions from where about the pH, about the habitat condition, whether it was dry, muddy, or aquatic, submerged, or floating. So that should be maintained, and then minor variations should be avoided. On the basis of the minor variations, one should propose a new varieties and new forma and all that. I'm against you. Minor variations, even if we are here, and if I go to Madras and living some few years, then apparent change will take place in me. So on that basis, that I cannot be changed that B N Verma 1, B N Verma 2. That's not a good. Normally, until unless you have not thoroughly, if you grow it, just I have seen Lepidopsis, when it is growing, it's showing so much highly branched thallus, and if you take to the laboratory and grow in the laboratory, it will turn into the unicellular form. What to say then? Then you just give a you also might have seen the cytomeres, tapering cytomeres. No, that was a developmental stage. That was later they discovered that tapering cytomeres is not a new species, that it is just a developmental stage of particular species. So these minor variations should be avoided, measured. Better the statistics have evolved a number of principles. So you take out the, prepare the exhaustive data of all the morphological data, and then you statistically analyze it. And after analyzing, if you are observing that characters statistically significant, only then you can propose any new thing. To me, it's my personal view.
Like, is there any key or monograph for identifying charophytes, sir? Like, well-established monograph, like
monograph or key.
Mauri has given a exhaustive key. My student also gave a key. That's very good key has been provided by Udani Mauri.
So,
Wood and Mori.
Udani.
okay, sir. And Like, what about the molecular status, sir? Like, molecular studies, are they reliable on matter of charophytes?
No. I have not gone through that molecular level charophyte. This is the work of my students, and after that, I have not worked on this charophytes. And molecular level, especially in Bihar, I'm working in Bihar, North Bihar. It's not, laboratory is not so much developed. Even the refined chemical test is not possible here. And just I'm now 80 years. Very well. I'm 80, 81. How you expect now? How much expect from me?
Sir.
Just
And
Mr. Chogule might have told you.
yes, sir. You are writing one book
Very,
also. Now also you are
that's
writing
why
one book.
the commitments and constraints that
Yes,
I am
sir.
writing, I have just completed many. So, but I have gone through the molecular level, every conception of this Central Medical Organization. When you will go to the molecular level, Parimal, then you discard everything and you will get in another world. So it's another world. I have seen, by writing, I could say that the prokaryotes, you say the centromere is not nowhere. It get attached with the cell wall and then it moves. Molecular level, it has been established in that cell wall, the cytometric organization that sequencing molecular level, it is equivalent to the centromere. So then the whole conception of prokaryotes, when you are going at that level, the whole conception of prokaryotes and eukaryotes good, that's invalid. So I'm not too much aware with that.
It's okay, sir. And what about the economic value of charophytes, sir? Is there any economic, socio-economic values?
Economical, mosquitoes, it repels mosquitoes and all that, but not economically, it's not very sure. That's why just see work stopped just after Y.S. R.K. Sharma and I retired. Thereafter, no work is going on charophytes. Have you seen anywhere working? Because every agency wants the economical benefit.
Economical benefit, yes, sir.
So naturally, since it is not having so much.
No biological value, only economical value they provide. They give funding to only the economic value, no biological value.
They finance it.
So it was a great session, sir. So I think we can conclude this session. So I'm here to propose the vote of thanks. So the second session of AARI International Algal Webinar for the promotion of Algology. I would like to thank our special guest, Professor B N Verma, sir, for readily accepting our invitation and delivering an insightful presentation. The in-depth knowledge of Professor B N Verma in the field of charophytes and their taxonomy has inspired all the participants. The lecture was extremely useful and he showed all the chromosomes pictures and the karyotyping pictures, many things. Those were like very interesting. And the photograph of morphology of Chiara was also too good. And many things he explained in detail. Those things all useful to the audience. Many audience were actively participated in the webinar and asked queries. Those queries were well explained by the Professor B N Verma sir. So I would like to thank Professor B N Verma sir once again for his wonderful lecture. And here I take this opportunity to thank Professor B. Chowdhury sir for being backbone of me for arranging webinars with such great personalities. Without his support, this session would not have been reached this height. Thank you, sir. I also wish to thank our audience for their great interest in the session and also for patiently listening to the speaker. I thank you all once again for your support. And last but not least, I would like to thank Board of Director and other staff members of AARI for supporting me in continuously arranging consecutive webinar sessions. Thank you all, sir. Thank you so much, sir. You have spent almost like you traveled 80 kilometers for this webinar, and thank you so much, sir. You took a lot of trouble for us.
That is partly due to the confusion and partly
Yes,
due to
sir.
the failure of.
Internet failures often happens to everyone.
Thank you. Thank you.
Thank you
Thank
so
you.
much, sir.
Thank you. Thank you very well, sir.
Yes, sir. Thank you, sir. Thank you.